Hi everyone, this is John Rancisqueta from BSECU 5A, and this is my presentation for a project Point-to-Point Microwave Communication Link. Let's start. Introduction. Microwaves are the waves that radiate electromagnetic energy with shorter wavelength. They are not reflected by a ionosphere. They travel in a straight line and are reflected by the conducting surfaces. Microwaves are electromagnetic waves with frequencies that range from approximately 500 MHz to 300 GHz or more. The prefix micro in microwave is not meant to suggest a wavelength in the micrometer range. It only indicates that microwaves are small compared to waves used in typical radio broadcasting, falling along 1 mm to 30 cm, which are slightly longer than infrared energy. And we all know naman na kapag gagawa tayo or magdi-design tayo ng isang project, meron tayong dapat na objective. So, the main objective of this project is to design a point-to-point microwave communication link with a path length of no less than 25 kilometers. Ito na nga, mag-start na tayo sa paggawa ng ating project. And bago tayo dapat mag-start, dapat alam natin yung madaming bagay na kailangan nating i-consider. So these are the things to consider when designing a point-to-point microwave communication link. So we have here site selection, Fresnel clearance, and microwave calculation. So, site selection. So, dito sa site selection, dito natin malalaman yung ating location A and B, wherein doon natin ilalagay yung ating transmitter at saka yung ating receiver. Ito namang site specification, dapat alam natin yung specific elevation ng ating site A at saka site B, yung specific latitude at saka yung specific longitude ng ating site A and site B. So, yung key-curve naman, earth bulge at saka key factor ay connected naman siya sa isa't isa. So, mamaya, madidiscuss pa siya ng mas maayos. So, as you can see, yung pinili ko na location is from Padre Garcia, Batangas to Lutucan, Quezon. So, sa pagpili ng location, be wise na lang. Make sure na maganda at magiging usable yung pagtatayuan natin. Meron kasi talagang location na hindi compatible or para lang mapagtagpo natin yung line of sight path nila, kailangan nating mag-adjust ng sobra sa ating mga towers. And ayun yung magiging reason kung bakit lalaki yung ating gastos sa gagawin nating project. So, site specification. Dito sa site specification, madali naman to once na meron ka ng location, madali mo nang ma-search yung elevation, longitude at saka latitude ng iyong site A at saka site B. So, yung aking site A is Lutucan, which has the elevation of 67 meter, longitude of 13.9071 degrees north. Yung latitude niya is 121.4828 degrees east. So, dito naman tayo sa Padre Garcia. So, yung elevation ng Padre Garcia is 166 meters. Tapos, yung longitude is 13.8777 degrees north. Tapos, yung latitude niya is 121.2444 degrees east. So, yung distance nila or yung path distance ng dalawa is 27 kilometers. Ito namang sunod na kailangan nating i-consider ay nakapokus siya sa surface ng Earth. So, K-curve. K-curve is a numerical figure that considers the non-ideal condition of the atmosphere resulting to atmospheric refraction that causes the ray beam to bend toward the Earth or away from the Earth. So, madidiscuss pa din yung Earth bulge. So, para natin mas maintindihan ng maayos kasi connected lang naman tong K-curve sa Earth bulge. For further discussion ng K-curve, yung K-curve kasi may kanyang-kanyang classification o iba't ibang condition. So, kapag yung key factor mo is less than 1, tinatawag itong substandard. In this condition, the microwave beam is bent away from the Earth. It is as if we expanded the Earth curvature or bulge or raised it up toward the beam above its true value. So, ito yung pinaka-curve or pinaka-peak yung value ng iyong Earth bulge or sobra yung Earth bulge mo or makapal. Ito namang second condition is kapag yung key factor mo is equivalent to 4/3. So, this condition was called a standard condition. Under this condition, the fictitious Earth radius appears to microwave beams to be longer than the Earth true radius. Ito din yung madalas na nagagamit na condition. So let's move to the third one. Super standard condition. Super standard condition is kapag ang K factor mo is greater than 4/3. In this condition, result in the effective flattening of the equivalence earth curvature. So dito sa condition na to, parang maganda lang kasi maliit na yung value ng ating magiging earth bulge. And the last condition, if K is equal to infinity. So this is what we called infinity condition or the flat earth condition. This condition results to zero curvature as if earth is flat and the microbeam follows the curvature of the earth. So parang ang perfect nitong condition na to kasi kung ano lang yung line of sight mo, ayun lang yun, hindi ka mag-a-adjust para sa iyong elevation or additional elevation kasi wala kang magiging earth bulge. Ito na nga yung earth bulge. So, what is earth bulge? Earth bulge is a term used in telecommunication, meaning the curvature of the earth's surface which limits the range of communication method that require a line of sight path, like high-frequency radio waves, microwaves, or laser. Para mas madaling maintindihan, i-explain ko ng kauntian pa. So, yung earth bulge yung reason kaya kapag umaalis tayo sa isang lugar is unti-unting hindi na natin siya nakikita kasi spherical nga yung earth. So, dito naman sa ating design project, para makompute natin yung earth bulge per elevation, kailangan natin ng distance 1, multiply to distance 2, divide 12.75K. Yung K natin, ayun yung pipiliin natin doon sa K factor, yung 4 na K factor. And so, kapag alam na natin kung under saang condition yung ating location, pwede na tayong mag-solve ng earth bulge. So, let's move to the next thing na kailangan nating i-consider. So, itong sunod natin kailangan i-consider is Fresnel clearance. So, what is Fresnel clearance? Fresnel clearance, it derives from electromagnetic wave theory that a wave front has expanding property as it travels through space. This factor must be added to the obstacle height to obtain an effective obstacle height. So, para mas maintindihan kung ano yung Fresnel clearance, imagine nyo na merong dalawa na poste, tapos meron kayong wire. So, yung distance ng dalawang poste is siguro mga 5 meters. Tapos, tatalin nyo dun yung wire. Tingnan nyo yung wire, may lundo siya or parang nagka-curve siya. So, yung curve na yon ay yung Fresnel clearance sa microwave. So, pansinin nyo din na nasa gitna yung pinakamababa na part or yung pinakalundo. Ganon din sa microwave. Yung pinakamababang lundo ay yung may pinakamataas na value ng Fresnel clearance. At ayon ay lagi nyo makikita sa may gitnang part. And to solve for the value of our Fresnels, kasi madami talaga yung ating Fresnel. So, gagamitin natin yung equation. Para makuha natin yung ating first Fresnel, kailangan natin i-multiply yung 17.3 sa square root ng first distance multiply sa last distance over frequency times yung path length or yung total path length. So, yung frequency kasi, malalaman mo yung value niya depende sa kung gaano kalayo yung distance ng iyong location A at saka yung location B or yung iyong path length. So, ganun naman. Sa second naman is yung ganun pa rin, 17.3 multiply sa square root ng second naman, second distance naman, tsaka yung second to the last na distance, tapos yung over frequency times yung total path length ulit. So on lang yon. So, mamaya makikita nyo naman yung aking solusyon na naka-Excel para mas maintindihan. So, ito nga yung computation ko. Ito yung mga value na nakuha ko gamit yung mga equation na ipinakita ko kanina. So, kasi yung makukuha mong value gamit yung mga equation na yon is sunod-sunod lang. Kasi D1, D2, tapos yung ano naman ay D2, D3, D3, D4. So, and so on. So, ganun lang yon. Parang pataas lang ng pataas, pa-improve ka lang ng pa-improve, tapos pabalik na ulit. Kasi, kukunin mo yung middle part at yung middle part lagi yung may pinakamataas na value. Tapos, kung mapapansin mo, after dun sa middle na part, pababa na uli yung value. So, di ba nga na-compute na natin yung earth bulge? Na-i-plot ko na din ito ngayon sa Excel. So, ito yung kinalabasan. So, kung mapapansin nyo, doon sa una natin, parang wala talaga siya. So, 0 yung ating earth bulge kasi starting point naman yon. Tapos, habang pumupunta siya sa gitna, lumalaki yung agwat kasi lumalaki yung earth bulge. Tapos kapag pabalik ka na sa dulo, lumiliit na uli. Kasi ganun yung function niya. Sa gitna, laging mataas. So, hindi ko pa naigagraph ngayon yung Fresnel kahit meron na tayong computation kasi wala pa naman tayong tower height. Which is, ayun yung important kasi dun magsisimula yung line of sight path natin. At the same time, yung magiging Fresnel zone path natin. And now, let's move to microwave calculation. In here, we can get the transmitter and receiver parameters, the path parameters, and the system reliability. So now, ang question natin is bakit natin kailangan i-consider yung microwave calculation? Siyempre, dito malalaman natin kung yung dinesign natin na system or yung dinesign natin na project is magwo-work. And bago tayo magsimula ng calculation, make sure na nakapag-search na tayo ng mga possible materials na ating gagamitin. So, ipapakita ko yung ilang datasheets ng gagamitin kong materials. And ito na nga yung datasheet ng aking antenna. Nag-search lang ako sa internet ng transmitter at saka receiver na merong 18 GHz. So, why 18 GHz? Kasi ayun yung pinakaswak para sa 27 km na distance or sa path distance. So, let's move to my datasheets ng aking tower naman. Sa pagpili ng tower, una mong gagawin is yung mag-estimate ka ng height. So, make sure na yung estimation mo dun sa height ng tower mo is swak or sakto lang doon sa iyong project. So, ang estimate height ng tower ko is 20 meters. So, dito siya sa Model T36 swak. Kasi, yung height niya nakadepende talaga sa pag-creation kasi mas mataas, kailangan mo ng mas matibay na tower. So, yung napili kong tower ay mid-supporting tower lang kasi 20 meters lang naman yung tower height ko. So, hindi ko kailangan ng sobrang tibay na tower kasi hindi naman siya ganon kataasan. So, additional information lang, nag-trial and error muna ako ng possible height sa Excel. So, nakita ko naman na yung ginamit kong 20 meters sa aking receiver at saka sa aking transmitter ay enough lang para magkita or magkameron ng line of sight path. So, let's move to calculation at mag-start tayo sa transmitter parameter. So, sa transmitter parameter, kailangan nating makuha yung transmitter power, transmitter transmission line loss, transmitter antenna gain, at saka yung effective isotropic radiate power. So, sa pagkuha ng transmitter power, gagamit tayo ng equation na PT is equal to 10 log multiplied to square root of PT over 1 watts. So, yung value ng ating PT ay 2 watts. So, kapag isinubstitute natin siya, magkakameron tayo ng value na 1.505 dBW. So, kapag naman sinolve natin siya sa NDBM, papalitan lang natin yung over doon sa loob ng square root ng 1 milliwatts. So, kapag kinuha natin in dBm, yung PT natin is equal to 15.05 dBm. So, sa transmitter, transmission line loss naman tayo. So, yung equation niya is LTX is equal to alpha over length multiplied to total length. Yung total length natin is 20, which is the tower height. So, kapag isinubstitute natin yung mga value, makukuha natin is 2.3028 decibels. So, transmitter antenna gain naman. So, dito meron tayong equation na GTX is equal to 17.8 plus 20 log F plus 20 log D. So, through substituting those values na kailangan nila, makukuha natin yung value na 42.9846 decibels. So, let's move dito naman sa effective isotropic radiate power. So, yung equation niya is EIRP is equal to PT plus GT minus LT. So, kapag sinubstitute natin yung mga value na yon, so magkakameron tayo ng 70.7349 dBW. And yung mga value na ito ay magagamit pa natin sa mga sunod pa na calculation. I-solve naman natin yung para sa path parameter. Sa path parameter, ang kailangan nating i-solve ay yung free space loss at saka isotropic receive level. Ang equation na gagamitin natin sa free space loss is 92.4 plus 20 log F plus 20 log D. So, i-substitute lang natin yung mga needed na value, makukuha natin yung value na 146.13272 decibels. Dito naman sa isotropic receive level, yung equation niya is equal to EIRP minus FSL. So, yung EIRP, yung nasolve natin kanina sa transmitter parameter. So, substituting those value, makukuha natin yung value ng IRL na equal sa negative 75.39782 dBm. So, dito na tayo sa receiver parameter. Dito sa receiver parameter, marami tayong kailangang isolve. Pero unahin na natin yung receiver transmission line loss, receiver antenna gain, net path loss, tsaka yung receiver signal level. Receiver transmission line loss. So, katulad lang din naman yung equation nito doon sa transmitter transmission line loss. Parehas lang din naman yung tower height, so parehas lang siya ng magiging value. So, substituting those value dun sa equation, magkakameron din tayo ng 2.3028 decibels. So, receiver antenna gain. So, parehas lang naman yung equation dito. Ang naiba lang is yung height ng antenna. Ang height ng antenna nila is 1.8, yung isa naman is 1.2. So, dito sa receiver antenna gain, makukuha natin yung value na 48.0109 decibels. So, net path loss naman. So, yung net path loss natin, may equation na siya na quantity LTX plus FSL plus LRX quantity minus quantity GTX plus GRX quantity. So, kapag sinubstitute natin yung mga value na nakuha din naman natin dun sa kanina, magkakameron tayo ng equivalent value na 59.74282 decibels. Dito naman tayo sa receiver signal level. So, yung equation niya is RSL is equal to IRL plus GRX minus LRX. So, isa-substitute lang natin yung mga value na kailangan niya. Makukuha na natin yung negative 29.6897. So, ito naman ay continuation lang ng ating receiver parameter. So, dito, kailangan nating masolve yung noise threshold, FM improvement threshold, carrier to noise ratio, tsaka fade margin. So, itong mga ito naman ay may given equation na. So, yung noise threshold, yung equation niya is negative 174 plus 10 log B plus NF. So, kapag sinubstitute natin yung mga needed value, magkakameron tayo ng negative 94 dBm. So, sa FM improvement threshold naman, yung equation niya is IT is equal to negative 94 plus 10 is equal to negative 84 dBm. So, yung negative 94 is yung N. So, baling equation niya, IT is equal to N plus 10. So, carrier to noise ratio naman tayo. So, carrier to noise ratio equation is equal to RSL minus N. So, isa-substitute lang din naman natin yung mga value na yon. Magkakameron tayo ng value na 64.3103 dBm. So, sa feed margin, yung feed margin equation natin is equal to sa RSL minus IT. So, through substituting the value that is needed na lang din, makukuha natin yung value ng feed margin na 54.3103 dBm. At yung value yan ng fade margin ang gagamitin natin para makuha natin yung value ng ating system reliability. Dito naman tayo sa system reliability. So, sa system reliability, dito na natin malalaman kung yung ginawa nating system is magwo-work. So, as you can see, mayroong table dyan. Dyan magsisimula yung equation na gagamitin natin para makuha yung system reliability. So, through that table, makikreate natin itong equation na 58 minus 54.3103 over 58 minus 48 equal to 99.9999 minus R all over 99.9999 minus 99.999. So, shift solve lang natin, makukuha natin yung value or yung ating system reliability na equal sa 99.9995673%. So, almost 100% yung ating system reliability. So, dahil ganun yung value ng ating system reliability, ibig sabihin, yung ginagawa nating project ay mag-work. At dahil nga na-prove na natin na mag-work yung ginawa nating system, ipapakita ko ngayon sa inyo yung final design, tapos yung mga computation, kasama yung Fresnel zone kasi hindi pa natin naipakita kanina. At ito na nga yung ating complete computation. Meron na ditong signal path at meron din tayong Fresnel zone. So ngayon, mag-move na tayo sa ating final design. At ito na nga yung kinalabasan ng ating mahaba-habang pag-compute, pag-solve, pag-estimate, at iba pa. So, kung papansin nyo, yung Fresnel zone naman is ayos. Ayun yung color white. Yung signal path natin ay yung green, yung yellow yung earth bulge, tapos yung ating red is ayun yung mismong terrain. At hindi naman dito nagtatapos ang lahat. Bago matapos ang lahat, syempre, project to, tingnan natin yung magagastos natin. So, dito tayo sa estimation ng ating cost. Yung mga possible na magagastos sa ating project. So, meron tayong supporting tower kit. 2 towers yon for transmitter at saka ating receiver. So, dalawa na siya. Ang presyo niya ay 775,083. 6 cents. Sa ating waveguide, ito yung kanyang description. Heliax EW127A elliptical waveguide. Yung 200 feet kasi parang set na yon, hindi pwedeng 100 feet. Pwedeng 100 feet pero by 100 kasi siya binibili. So, bali 200 feet, 198,000 yung cost niya. So, transmitter antenna at saka receiver antenna ay same lang ng price. So, yung total cost sa ating cost estimation is 1,125,190 and 14 centavos. And I think pwede na ito para gawin as a project. Thank you for watching!